Hello, what's up, and welcome back to another video. So in our previous video we actually got a little bit overview of what we will be doing in the overall course and all the types of machine learning that exist out there. We actually learned about those, and we actually also learned what is the supervised and the unsupervised learning and the methods that are involved in each and every one of them. Now we are coming to the more practical aspect. Now, why do you just go ahead and don't use the machine learning algorithms? So there is there's a problem in using the machine learning models, and that is that their limitation of understanding the data. So every model receives some sort of data on which it actually gets trained. So what this really means is that we need to pre-process our data before we can feed it to our machine learning algorithm. So this is where the data preprocessing comes under play. What I mean is that data preprocessing becomes a very essential part for any kind of data scientist or any kind of machine learning engineer to actually pre-process the data before he could just start using the algorithms. So as you can see that I have attached a step diagram here. This is actually showing the stages of how you bring in the data to the part where you actually start gaining the insights from the data. So the first step, as you can see, is the raw data. So we are somehow getting the data from some sort of data source. It could be anything. It could be the data that you have scraped from the web. It could be a CSV file. It could be your MySQL data that you have imported from a database, or it could be any file format that you're using. And then what you do is you structure the data. So what does it really mean by structuring the data? So how is your data represented? Is your data in a tabular form? Like, are you talking about the rows and columns? Or is your data in a CSV file? Like, are those the comma separated values? Or, if you're talking about the MySQL database, that is again the tabular form. So there are multiple data formats that you can actually, in which you can actually structure your data, or your data might even come in a pre-structured format. So if you're talking about the CSV file or a MySQL data, it already comes in the tabular form. And then comes the data pre-processing. So as you can kind of get the idea that most of these parts are actually very easy to do, because sometimes you already are at this point where you have the structured data, and all you need to do is you need to pre-process the data and you start working with it, right? So in data pre-processing, what do you really mean by data pre-processing, first of all? So let's say when you're actually importing the data, or if you're getting the data from some sort of a data source, the data that you're getting has some sort of null values, has some values which are irrelevant. The data contains the outliers. Now the outliers are this is the data that is not following a pattern, that is not significant in your data set. So how do you remove those outliers? How do you remove any useless features from your data and only keep the important ones that are necessary to train your machine learning algorithm? That this is where the data pre-processing comes in. And then we move on to the advanced part, where you actually perform the EDA on our data, which is exploratory data analysis. And then in the last part, we finally start gaining insights from our data. So we know what our data is, but we want to learn it, or we want to actually understand it deeply. This is where we actually use the plots. We actually use the plotting libraries. We use the visualization to understand how our data actually works and exactly what are the patterns. So we might discover something new in the data, but that's where you start gaining the insight from data, right? So in the next part, I'm saying that bringing in the data. So how do you bring in the data in Python? As I already told you, that we will be using the NumPy and Pandas and scikit-learn libraries for the machine learning, and more libraries that we can actually use to, as we move along, and as we actually start getting the need of more and more stuff, we will be increasing our set of libraries that we were using. So in this, initially I'm just going to go ahead and use the Pandas library to import a CSV file. So I'm just going to go ahead and first, before I actually import this file, I'm going to show that I have the CSV file saved right here. And what I'm just going to go ahead and do is I'm just going to import this file. So as you can see right in this line, what I'm doing is I'm just importing the CSV file of a Pima Indians dataset that I downloaded from from Kaggle, and you can actually get it from anywhere, but a good source would be to actually download it from Kaggle or any good data source that you might know. And then what I'm doing is I'm actually going to go ahead and I'm renaming the columns. Alright, So there are simply a lot of columns that I've renamed, and as you can see that all of these are the column names. And what I'm going to do is I'm just going to go ahead and print this data. So if I just do this, you can see that I have imported this data frame. I've imported the data and I've renamed the columns, and as you can see that right now I have a data set with different attributes, and this whole data set could be considered as an object. So you kind of get the idea why I actually imported this data was to actually give you an idea what are attributes. So if I ask you what are the attributes in this data set, so the attributes in this data set would be this preg, the class, price, the skin, test, mass, the pedigree, age, and the class. These are the attributes of our data set, right? So moving on. So now it's very important to understand what kind of data are we working on. So to summarize this, you can see that the data can be classified into two types. The first one would be to actually classify, or the first type of data would be the discrete or the qualitative data, and the second one is the continuous or the quantitative data. Now what do you mean by the discrete? The discrete data is when you actually are working on a very particular value. So this could be a percentage, right? So what I mean by percentage is that this percentage depicts, or it actually depicts the uniqueness of some attributes. So let's say I'm talking about a population. So the population of male is 72% and the population of female is 28% out of the whole 100% data, right? So as you can see that the percentage is also a discrete value that depicts the uniqueness of an attribute. Like the male are 72%, this is a fixed number and it doesn't lie between a range. And when I'm talking about the continuous data, this is the data that lies between a range. So I'm talking about, let's say I'm talking about, for example, I'm talking about the stock prices. So the stock prices for a particular day is going to be between $1 billion and $8 billion. So what do you actually understand from this is that I'm talking about the continuous data that is varying over attributes. So the weight of a tree would be different, the weight of a human being would be different. So the values which actually vary between attributes and that actually lie between a range, now these type of values are called the continuous values or continuous data. And then we actually have different techniques to represent this data when you're talking about the tabular form. But this is not where we want, this is not what we are interested in. We are interested in actually this. How do we visualize this data? So the graphical methods to visualize a discrete data would be possibly the bar graph and the pie chart. So as I already told you, if you wanted to represent the population of male and female, you could just go ahead and draw a pie chart in which the bigger portion would be representing the male and the smaller portion of that pie would be representing the female, right? And if you want to we wanted to represent the continuous data, let's say the stock prices, so the changing stock prices for every single date or every single day or year could be represented in a form of a line plot, in which a line is going up and down and up and down. So you kind of get the idea. So as we move along, as we actually go ahead and start working with more of the data sets, I'm going to be using these techniques. So you're gonna get a very good idea of how we actually plot our data, how we visualize our data. So to summarize and to make things very clear for you, I came up with these 7 recipes to understand the data in a better way. So the number one recipe is to actually take the peek at your data. So how do we take a peek at your data? We already saw how we can actually go ahead and import our data right here. Now this is actually taking the peek at the data, but there's another function in pandas that you can use to peek the data. Just without actually looking at all the rows, you can just go ahead and take a look at the first 5-6 rows and get the intuition of the data, like how the data is and what kind of pattern is it following, what are the attributes, am I working on the numeric values or am I working on some alphabetical values, am I working with some strings, or am I talking about some classified data. So this kind of information could be gained at the first look, at the first insight of the data, right? So what I'm going to do is I'm just going to go ahead and say data, which is my data that I've imported in, and then I'm going to say head. Now head is the function of pandas that helps you see or view the first 5 rows of your data, or you can even pass in a number to actually increase the rows. So you wanted to get, let's say, the first 8 rows or the first 100 rows of the data, you can just go ahead and say this, and you can see that you instantly get the look of your data. So what do you understand from this data? You can see that all of our attributes are numeric. There's no alphabet, there's no string in our data, which you can which you understand that this is a numeric data. So all of the techniques and mathematical, the statistics or all the techniques that you will be using will be based on the numerical attributes, right? So now talking about the second recipe is reviewing the dimensions of your data set. So what do you mean by the dimensions? Alright, so I'm just going to go ahead and put a comment here that we're talking about the dimensions. So how do you get the dimensions of a data set? So the dimensions is simply, in other words, you can just simply say that you can write shape, and what it will actually show is that we have 768 rows and 9 columns. Now this is what exactly is meant by the dimension. As you can see, there's a single comma, which means it's a 2D data or a two-dimensional data, in which we have some values on X and some values on Y, and then if you're talking about a three-dimensional data, let's say it's an image. So an image is a three-dimensional data. Why is it a three-dimensional data? Because an image can be represented in a form of 3 frames. So the first frame would be the red, green, or blue, and as we move along, we're going to actually understand how we can actually work on even the three-dimensional data. So you can see that we only have this two-dimensional data, in which on the one side we have the rows and on one side we have the columns. Alright, so the third recipe here is that review the data types of attributes in the data. So pandas has a function called the data dot so this is an attribute called the d types, the d types, and when you print this out, you see that it instantly gives us the type of the numbers or the data or the type of each and every single attribute of our data set. So you can see that the first few attributes are integer, and we also have some floats, and then we also have some integers again. So you can kind of get the intuition of how your data is, and as you process the data, you will kind of get the idea that whether you want the perfect values, or in that case you might be using the float values where you want the accurate information, or you might be working with the whole numbers where you might be working with the integers, and so on. So our fourth part is this to summarize the distribution of instances across classes in your data set. So how do you summarize the data? Alright, so how do you summarize? It would be very simple actually, because all you need to do is you need to just go ahead and print the number of classes. What you can do is you can just go ahead and say columns, and it will just go ahead and give you the number of columns that are included in our data set, which are the names that I set at the initial phase. And then what you can do is you can actually go ahead and get more information of what is exactly happening in your data set. So I'm just going to go ahead and comment out. Actually, I'm going to leave it the way it is. The fifth part is summarize your data using the descriptive statistics. Now this is where most of the statistics knowledge that you might need will come under play, because as you already know that you should have some information of statistics before to understand the data. So I'm actually going to go ahead and give you a very quick overview of what kind of things that you might be needing to understand the data. So the terminologies I have written here is the count, mean, standard deviation, minimum value, maximum value, and then these are the percentiles that are that we have some percentile of data, then we have the 50%, the 75% of the data. So we actually go ahead and slice our data in different parts. So I'm actually going to go ahead and explain each and every one of these one by one. So first of all, what I'm going to do is I'm just going to go ahead and say data dot, and if I press tab, I will instantly get the IntelliSense for what I'm about to write, so that you kind of get the idea that in Jupyter Notebook you can just go ahead and press tab and get the idea of the number of attributes that you might be writing. So what I'm going to do is I'm just going to go ahead and write count, and I'm just going to go ahead and print how many number of rows or how many records I have in my data. So if I just print this, see that it instantly gives me the count of the data, and you kind of get the idea that these are the number of rows, and you can see that we have 768 rows and 9 columns. we instantly get the idea. Now what we need to do is we need to actually go ahead and print out, let's say, the mode of our data, or even the mean. So what is mean? First of all, if I ask you what is mean, so the mean is simply the average of an attribute. So I'm talking about, let's say I'm talking about the stock prices. So the stock price for day 1 was 5, the stock price for day 2 was 6, the stock price for day 3 was 7. So what would be the mean? The mean would be the average, so which means that I would be just summing up all these values, which would be 5, 6, 7, and then I would be dividing this with the total number of records that I have. So if I was talking about these 3 days, this would be 5 plus 6 plus 7 divided by 3, and so on. So if I wanted to take out the mean for a particular column in my data, what I would just do is I would just simply go ahead and say mean, and that's it. If I do this, you see that it actually instantly goes ahead and takes out the mean of each and every attribute and prints it out right here. So what it is doing is actually printing out the mean for the PREG, the class, the press, the skin, test, mass, petty. So it actually gives us the mean of each and every attribute, and we can actually go ahead and calculate the standard deviation. Now, standard deviation is the amount of spread or dispersion in your data that there exists, right? So there might be data that is not that much related to each other, that is not that correlated. Again, what is correlation, and what do you really mean by correlation? I'm going to be talking about this in my next video. But for now, you just should know that we are actually using a standard deviation to find the dispersion of our data. So what is standard deviation? It's simply finding out the dispersed data, finding out what are the dispersions, or like how is our data distributed in different dimensions, or how is our data distributed and how much related our data is, right? So now the second thing is the minimum value. So if you wanted to print out the minimum value of each and every attribute, I will just say min, and if I print this out, you can see that it instantly gives us the idea that, you know, in first attribute the minimum value is 0, in the second attribute, in this attribute age, the minimum age is 21, and yeah, and so on. Or you can do the same for max. So if I just do the max, it gives us the maximum value that exists in each and every attribute, and so on. If you wanted to calculate the mode of the data, what you could do is you can just say the mode, and it will instantly give you the mode. So what is the mode? Mode is the most occurring record in the data set. So let's say the stock prices for a year, for a week, was 2 billion, 3 billion, 2 billion, 2 billion, 5 billion. So you kind of get the idea that 2 billion is the price that is most occurring. So the mode of this data would be 2 billion, right? So this is exactly what it's doing here. And so you don't have to individually print this out. The pandas actually provide us with a very special function, which is called the describe function. What this describe function does is, when I actually print this out, you see that it instantly calculates everything for us, and it gives us every single thing. So it actually gives us the count of the data, it gives us the mean, it actually prints out the standard deviation, it prints the minimum, maximum, even the 25% of the data, the 50 percentile, and 75 percentile, and the maximum numbers occurring in each and every one of the attribute, right? And so now you actually got the idea what this is. Now we can actually move on and understanding what this diagram is saying. So you can see that this diagram represents the skewness of the data. So this is a density plot, as you can see, and this is a density plot of a certain attribute, right? So this could be a density plot of a stock price, this could be a density plot of an age, but let's just talk about the age for a second. So let's say we had the ages which are increasing, and then we have an instant decrease, and as you can see that our data is more towards the negative side instead of the positive side, or simply the positive side instead of the negative side. So you can see right here our data is skewed, or it's more tilted towards the positive side. So what this means is that our data is positively skewed, and at this point the median of our data would be lying somewhere about here, the mode would be lying somewhere about here, and the mean would be lying somewhere about here. But on the other hand, it would be in the negative skewness, this would be a completely opposite. And then if all the things are, if our data is perfectly symmetrical, if there's no skewness in either on the positive or the negative side, then we could instantly detect this kind of condition by printing out the mean, median, and mode. and the mean, median, and mode of that data would be the same. So if you kind of look at this data, you can kind of see that the mean, median, in most of our attributes there is no condition where our data is symmetrical, because in real life it's very rare that we actually find a data set which is perfectly symmetrical, right? So our fifth step was to actually summarize the data using this descriptive statistics, and the second last is this: understand the relationships in your data using the correlation. Now comes the part where we understand the correlation. So now, what is the correlation? In simple words, correlation is how you define the relation of all the attributes. So how much related is the PREG with the age, or how much related is the mass with age, like what is the amount of relationship between these attributes. So we can just go ahead and use the pandas COR or the correlation function to actually print out the correlation between each and every attributes. And what this function will return, it will return a matrix. So you see, if I press enter, it returns a matrix of correlation between each and every attribute. So you can see the PREG with itself has no correlation, so it has a correlation with 1, which means they are highly correlated. And you can see the attribute, the correlation of an attribute with itself is 1, and there's a diagonal of 1 in right away. So you can see that there's a 1 in diagonal, and then we have different correlations. So the correlation function, what it does, it simply goes ahead and prints out the correlation. And then in our further videos, we'll be understanding there are different methods for finding out the correlation. There's the Pearson correlation, which actually goes ahead and normalizes our data to lie between -1 and 1. And there are different formulas that we can use to print out the correlation of our attributes. But for now, you just kind of get the idea that how you actually print out the correlation. So these are like the 7 recipes to actually get the idea. So you can see I've already told you how you actually view the skewness of the data, and you kind of get the idea that if you use these 7 recipes, it would be quite easy to actually experiment with the data and to get the good insight of how your data is behaving. So what kind of trend is going on? Is the average? What is the average of your data? What is the mean of your data? What is the most occurring value of your data? So with this knowledge, you can actually go ahead and start plotting your data in a form of a density plot, or in a form of a histogram, and gain some good insights from the data before you actually go ahead and put it or feed it to your machine learning model. So that's it for today. I hope you enjoy this video, and don't forget to like and subscribe. And in our next video, we will be learning the more interesting stuff in the data preprocessing. We'll also be learning about the correlation. We'll also be learning about the visualization. So stay tuned for that. Adios.